Welcome to Electricity and Magnetism, Part 8C, Series Circuits. And in this part, we're going to talk about the total resistance of series circuits and the voltage drops. As you can see on your screen, a series circuit has one loop, sometimes called a leg or a branch, and the current is the same everywhere in a series circuit. There's only one path, so electrons can only go in the one way. Now we talk about the total resistance of a series circuit, and we say the total resistance of a series circuit is found by adding the resistances of all the components. In mathematical format, total resistance is equal to the sum of the individual resistances. Now, a quick example. Find the total resistance of this circuit. You see we have one loop. We know the current is the same through every resistor and every place in the wire. And total resistance is equal to the sum of the individual resistors, which is R1 plus R2 plus R3 plus R4 plus R5. Here we added, just replaced the R1s through R5s with the actual resistances, add them up, and we find out the circuit is a total of 60 ohms resistance. Now, what is voltage drop? Well, voltage drop is the amount of energy that required to pass electric current through a resistor. Remember, voltage is a measure of energy, and to go through a resistor, the resistor uses up some of that energy. So if 100 volts goes into a resistor and 20 volts comes out, we say there's an 80 volt drop. And in a series circuit, the sum of the voltage drops is equal to the voltage supplied to the circuit. So if we supply 100 volts to a circuit, by the time the electrons flow through each individual component of that circuit, 100 volts of energy will be used up. Example, find the total resistance, voltage supplied, and the voltage drop for each resistor in this diagram. Is the sum of the voltage drops equal to the voltage supplied? And it's a pretty straightforward circuit. We have 2 amps supplied by the power supply. We have 3 resistors with 3 different resistances. Now, how do we go about finding a solution? Well, first of all, we find the total resistance, which is merely the sum of the 3. Turns out to be 75 volts. Voltage drop in resistor number 1. And remember, the amperage is the same everywhere in the circuit. So voltage drop 1 is equal to I times R1. Do the substitution, you get 40 volts. Work through V2 and V3, you get 50 and 60 volts. And the question is that equal to the voltage supplied to the circuit? Now we know that the voltage supply is 150 volts. We've calculated that already. We add the voltage drops, 1 through 3. You find out there are 150 volts used up in the circuit. So yes, the voltage supplies does equal the sum of the voltages of the voltage drops in the circuit. Gee, I hope that helped. Please feel free to leave a comment.